All right, let's get started. Welcome to the session on large-scale telemetry and analytics with DSLs and machine learning. Today's session is going to be a mix of some overview and then mostly spending time on demos. So this is really going to be a lot of code and experimental work. So I'd love to be make this interactive and engage in Q&A as we see. The agenda, if you could go to the next one. We'll spend a little bit of time talking about the technologies and scope. We'll give you an idea of what the platform really looks like. And then we'll talk about telemetry and visualization and show you how to use DSLs to integrate these two together. We'll then talk about some of the regression and confidence building techniques to a particular use case, again with DSLs. And then we'll show you some of the predictive analytics that you can really do also with DSLs, and then wrap it up with a summary and question and answers. Next one. My name is Murali Kaundinya. I run engineering within a small group called Applied Technology within Merck in branch work. We really look at some of the disruptive technologies that are applicable in the healthcare space, and we do prototypes and proof of concepts, and then transition some of these products into the divisional ITs for them to really use. Some of them are very futuristic, applicable in the 2 to 5 year time frame. We're based in Branchburg, New Jersey, and we are hiring. So I'd like to introduce my colleague, Gopi.
Hi, my name is Gopi. I've been with Merck, especially in the healthcare industry, for 15 years. I work with Murali. We both do engineering in applied technology. We do projects which are Horizon 3 in the sense of looking for futuristic 5 years from the line and see how that can be used in the healthcare space. So that's what we are doing, and that's one of the things which we were experimenting and playing around with, how to leverage DSLs and use them in the healthcare space for making analytics easier and simpler for the data scientists.
Okay, we wanted to acknowledge contributions from a summer intern as well as our colleague in Prague, Jakub Katowski from Prague, as well as Semyon. So the problem space that you're really looking at, the next one, is there is an explosion of data. So if you really look at this chart, the advent of digitization and digital technologies is really ushering in a lot more data as it's thematic of this conference. And as you really look at how they are really applicable in the healthcare space, we've been focusing mostly around disease diagnosis and management in the healthcare space. But as you really collect telemetry at very large scale, there is an opportunity to really get preventative and even benefit from some of the predictive work that we can really do, right? I'll show you some of the evidence on how this is really looking to be promising in terms of really getting aggressive with some of the treatment, right? Just to really give you a sense of what is really going on. Today there are about 64 million genomes that have been sequenced, right? If you go to this company called 23andMe, for about $100 you can get your genome sequenced, and they'll actually tell you the sensitivity that you may have to certain drugs and identify a dozen or so biological markers. So clearly what we are really seeing with precision medicine and personalized medicine is beginning to come to fruition, and in terms of commercial offerings such as this. And again, we are technologists. We are not really well versed in the the healthcare domain. But what we really want to do is integrate and aggregate some of the technologies that can be really be brought to bear to really have an impact on getting aggressive with treatments, particularly with preventative therapies. Next slide. So this is a chart that really tells you the business impact. In 2015, the amount of money that is really flowing into the digital health trends is just staggering. It's like $6 billion. there are like 900 deals that have really come to fruition. And when you really look at the other chart, the prospect of saving money, particularly when getting preventative advice, is staggering. I mean, the evidence is really compelling. All of this is really happening because you're now able to process large amounts of data and act upon that data, right? So clearly the trend is that in the next 5 years, the savings will be cumulative of about $100 billion. That's basically what the statistics are saying, right? So if you really look at the predictive aspect, right, this is a chart that was produced by Optum. And for congestive heart failures, they have shown that the percentage of patients who were really admitted to a hospital was pretty close to what they had really predicted. 95th percentile, 55% of those patients were actually admitted into the hospital, just as the prediction really stated. This is just an indication that if you were to really spend more time in analyzing the data, you can really get ahead of the curve and really get patients to really take action to something that might really be happening in their lifetime. Next slide. So we've actually compiled quite a bit of data around how these devices are really playing a role. There is also a lot of hype. When you really look at the hundreds of thousands of apps that you really see in your mobile devices, many of them are playing at the periphery of what you could really be doing with them. So you have to really probe a lot deeper to really see what amongst them are really applicable to dealing with the real problem. If you look at the devices that drive better outcome, there's a good chance that they'll really have longevity in this space, right? The key things that you really need to look for in the devices are they really increasing the quality of care? Are they really reducing cost? Are they really reducing hospitalizations? So the chronic diseases are the ones that can really benefit the most. And recently the FDA regulations definitely increases the reliability and the quality of data that's coming from these devices. So the applicability of standards and the regulatory aspect cleanses the amount of data for us to really act upon. Next one. So what we want to talk to you today was to show you how you can integrate the data from these pervasive devices and build an end-to-end solution. So on the one end are these various types of sensors, devices, wearables, phones and PHRs and EMR systems. And they are really getting aggregated through a variety of machine-to-machine protocols. They are very conscious of the resource constraints that these devices suffer from. And they come into an aggregation layer, right? And the aggregation layer then ingests these data into this ingestion layer where it's getting stratified, and then it's getting into the analytics layer, right? And as you can imagine, that is supported by the machine learning platform that is really doing all the heavy lifting. And once you have really done all of that heavy lifting, you really need to be able to visualize for you to really act upon. And that decision making can really be done through a patient portal, a provider portal, a payer portal, et cetera. And so that's basically the consumer of that enriched data that they're really going to act upon. So that's basically the backdrop, right? So these are the Hadoop technologies in scope. If you go to the next slide. So what we really want to show you is a use case similar to what we saw in the 2009 flu pandemic, right? If you were to really see how patients who are really transmitting data about their health and wellness, and how we would really be centrally coordinating the collection of all of the data to really see how many patients are at risk for a particular strain of flu. How do you really analyze how that is really migrating from one location to the other? how do you really go about predicting the occurrence of these diseases in these locations, and how do you really go about stocking up enough medicine to really treat these patients. So that is just a broad use case. We've seen this from 2009. So what we really want to show you is, how would you really go about putting together the various, technologies and tools to realize something similar to that. Okay. So I'm going to turn it over to Gopi, who's going to show you, some of the demos on how we really integrate the two together.
Okay. Go ahead. You have some questions?
Yeah. What's DSL? You keep referring to DSL in your
DSL stands for domain-specific languages.
Okay.
So if you are a scientist, or if you're an expert working in your domain, you do not want to be overwhelmed with all of the technological details about learning various programming languages and computing paradigms. So there is an opportunity for us to really create exactly a tool that allows you to work in your domain, whether you're a biologist or a chemist or somebody with some specialization. Okay.
Okay. So before we get started with the demo, I just wanted to spend a few minutes to talk about this wearable landscape today. With all these devices out there, I mean, just noticing out of, if you take 5 out of 10 people, you see them today wearing some sort of a device or a wearable for health reasons, for fitness reasons or whatnot. So there's a big opportunity in the healthcare space to tap into these data in the name of patient or these user-generated or reported data, and that can be used in a lot of ways, right? Say, for example, a wellness app. If a payer or provider wants to use these type of devices to basically monitor somebody with diabetes and recommend that look at their activities and their sleep patterns and recommend some sort of lifestyle changes. So there's a lot of potential with these type of devices. And there are so many devices out there. If you walk into some of the electronic store, they have their own aisle now, which has multiples of devices from dropping out each and every week. So with this, such a array of devices with different companies, different technologies, even from the way they are used in the wearable space, there comes a lot of challenges along with it, right? I just wanted to talk about a few of them. First thing is, with these too many devices, all these devices are basically as their own way of providing the data ultimately. See, for instance, one good thing is all these devices let you access the data or let you share the data with somebody else through a proper authorization mechanism. However, their standards in which they share the data or the contents are totally different. So not every of the devices gives, for example, your activity in a same way. For instance, Fitbit gives you in a different way, Misfit gives you in a different way, Jawbone different way, Apple Watch different way. So they all have their own standards of giving the data. There is no one defined standard of exchanging this data or sharing this data across. That's one big part of the challenge. And the second part of the challenge is units. They all talk in different units. For instance, if you look at Misfit, it's standardized to some extent in the metric system, whereas certain devices in the local units. So they don't speak the same language, or they don't share the data in the same consistent way. So that's another challenge in this device space. However, the good thing about this is all of these devices are fairly accurate. Accurate in the sense they cannot be used in the clinical context, meaning you cannot use those metrics or the data provided by these devices to diagnose something, but you can definitely use these devices in the wellness context, meaning you can basically use it in the disease management program, but not really a disease prevention or something like that in the clinical context. So that's the extent of usage of these devices today. On the other hand, there is also point of care devices, which are like your blood pressure monitors, blood glucose, which you do it at home, not necessarily you have to visit a lab or a clinic to do such type of things. They can be used to somewhat keep in check your sugar, your blood sugar level or your blood pressure level to some extent, as purely in the context of a patient reported data or a user reported data, but not in the sense of clinically significant data. So, there are some various type of devices out there. On top of it, there are also apps which are generating this type of data. So, for instance, many people use some sort of a food diary app if they are in a weight management program or a diabetes management program. So, there is a lot of apps out there coming out, they start transmitting the data, and most of the cases these data needs to be some sort of a near real time basis for certain type of actions to be taken on those the events which arises out of this data anomalies, right. There is also companies which are forming right now. There are data aggregators like there is a company called Validic. What they do is they aggregate all these variables and they standardize this data and they provide the data through APIs. And there is a companies like Human API, which actually is a company which almost works with all the popular variables which are out there today. And you can, and they, what they do is they enrich the data in the sense of adding some sort of clinical context to it and also standardize the data and make it available for consumers to use it. So, while these companies are forming and making the data sharing aspect of it seems easier, but still there is a lot of work which needs to be done in the space, and it is right now scratching the surface. It is just starting up. It is not really there in a big way where you can take this data and use them in a wellness management program or a disease management program. So, that is the landscape today. So, what we have done is, as part of this demo, one other thing what we wanted to do is we are exploring the possibility of using a DSL in the sense of, if I have a use case, if I have an idea of exploring a data, an event from a data, and I wanted to do some sort of an analytics or a visualization or an event triggered based on some things which we are seeing in the data, which calls for a physician communicating to a patient or a physician communicating to a user and telling in advance what type of situation is he in, or what's the telemetry tells that there is some sort of a problem with, say for instance, his blood glucose level or his activity level. So, we wanted to make that aspect of coming up with the kind of this analytics on the fly without having to sit with a data scientist or a IT guy to basically look at the data, write some reports, write some queries, and then basically act upon it. Rather, make it easy where the practitioners or the physicians can, to some extent, easily do these type of analysis or this type of detection, signal detection using this DSL framework. That is the part of the demo which we wanted to basically share today. What we have done so far is we have created a prototype of a DSL language, and then we have basically experimented with various substrates, and I will go to that in a little bit more detail what those substrates are, and as we go through the demo I will explain them, and see how an end user who has a knowledge of clinical and the data, but not necessarily have to have a background in an IT or understand the programming aspect of it, and how he or she can basically quickly whip up a analytic use case and basically be productive with respect to the data. So, that is what going to be the part of the demo. So, I will switch over to the demo. Okay, you are able to see this? So, we keep saying DSL, right? I think somebody asked what's a DSL. Before we go into the writing a DSL to just illustrate a use case, I just wanted to talk about the technologies which we are using here. These are used purely as a proof of concept to make sure that the DSL is sound enough and basically is going to help validate these use cases on the fly without having to go through a lot of programming churn. So we have divided these substrates into 4 categories, right? Acquire, synthesize, learn, and action, right? Acquire obviously is getting the data, acquiring the data, right? In the acquire substrate, you just go and basically say, I wanted to get this data from a streaming data feed, which is transmitting a GPS location of a patients who are all using this app and traveling across the world, right? What would that be used for? I could basically monitor the flu epidemic in that area, and if this person has some sort of condition which he or she needs to be notified, then I can take action immediately and basically let the patient know that this place is not safe for her, or she has to take, or him, and he or she has to take extra precautions while visiting this place. That's one simple example. Streaming data from GPS channel. But this could be also be a streaming data from one of the wearable devices, my heart rate continuously getting streamed, where somebody can monitor and give some insights or gain some insights out of that and basically notify the person. Then the synthesize is, okay, once I acquire the data, I may have to do some additional processing on the data. Basically, I may have to select few attributes from the data for further processing or acting upon it. One example could be, I can go to my database and look at all the patients who are taking allergy medications, and I wanted to understand the distribution of the medications taken by patients across regions. I wanted to visualize them to see what type of allergies exist and what are the medications which are taken by various patients at various locations. That's an example of synthesize. The learn is I can do some sort of learning on the data, meaning I can employ some sort of a machine learning on top of the data to do some sort of a linear regression or a logistic regression and figure out or group the data into, okay, I wanted to group how many of the allergy seasons by geographic locations. I wanted to understand the allergy or pollen count over a period of months and how they are being distributed across the regions and so on. So that's an example of a learn. Or I can construct a neural network and basically do some sort of a training pattern on those and figure out, okay, given these type of conditions, what's the possibility of having an allergy season to be low or a high pollen count to be low on this particular area on a particular date. So those type of things I can do on the learning substrate. And the final one is action. So once I get the data, I wanted to visualize the data. So for instance, now I am going across the pollen area, my pollen landscape, looking at pollen across various locations, and I wanted to visualize them in a map, kind of a heat map, seeing, okay, where there's a pollen counts are high, where it is low, and so on. So I can basically inform my patients who has allergy and tell them that if you are traveling to this area, since you have the allergy condition, so take precautions or take medications and so on. So we just divided this into these 4 substrates, and I'll just show you a simple example by creating example of creating a simple use case without having to go through a lot of programming, right? So just script name, I'm just saying allergy. So in my acquire phase, so here's the thing. Most of we are using this framework called MPS, which is Meta Programming System, which is not a textual editor. It is an editor based on AST, Abstract Syntax Tree. In other words, it's like a tree-based editor. And what it gives you is, this is called projectional editing, meaning everything you edit here is not stored as text. It's stored as a node in a tree, which lets you practically as a user doesn't have to understand the nuances of programming language. What I mean by that is, if I just go here, I see, okay, there are 2 options available, channel. Okay, now I'm saying, once I choose the channel, it's telling me channel from stream, and it's going to tell me what are all the streams available right now. So there is one stream called GPS stream which is available, which is actually sending GPS coordinates from all the patients who has this app. Let's assume that we have an app which actually tracks the location of the user, and it also tracks the environments so that that information is transmitted through the stream real time, which hits the system. So what I am saying is in the acquire phase, acquire the data from this GPS stream and name it, say, GPS data. Okay. So now I am getting the data, I am acquiring it, and I am naming it GPS data. Now I am saying action, I am say map from this channel GPS data. That's it. This few lines of code, without having to understand the syntax and without having to understand the nuances of what to do with the data, how to process this data. Now I have a program. When I run this, it's going to basically take all the streaming data coming in from these users, and it's going to show you in a map. Okay. Let me quickly run the demo and show it to you. So ultimately what it does is it at the back end generates a Java code. Now this actually uses this MQTT, which is a M2M protocol which Murali talked about, where where we have a topic called GPS, where all these apps which the users are using are publishing their coordinates into the topic called GPS, and that's pretty much it. So, but it abstracts all these things from the user, so that with those few lines of code, it generates the Java code like what you are seeing on the screen, and when I run this, it's basically going to display the map. Now, there is no real users right now, right? So, I have to simulate that, and let me go ahead and simulate like 5 users transmitting their location at any given point in time, right? So, I am going to basically randomly have a test data which is simulating 5 users sending this data, and then once this data is getting streamed, you are going to see them in the map appearing here. So, you see all those 5 users from 5 different locations are basically transmitting their data. So, this is just a simple example where you can just with very few lines of code, without even knowing what that code does, just by using the projectional editing capabilities, you can create a DSL program which can run and do this type of visualization for you.
So in the real life setting, what would have really happened is these patients who have really enrolled in some sort of a population health program would have opted in to transmit their health and wellness data, and the central portal that is really collecting all of the data is now being able to act upon their health and wellness information. So if there were to be alerts that needs to be pushed into those users, now you can do so. So in Gopi's simulation, we have simulated the distribution of allergy conditions across various zip codes. So if you're really running into a location where you're likely to have a new allergy affect you, we can then push an alert back to the user saying, hey, you need to take such and such precautions. That's what that demo shows.
Okay. So then the other one which we talked about is also a use case where we say, for instance, let me close this and go to the next DSL. So here's another example which is not coming from a streaming data or coming from some sort of a telemetry where the devices or apps transmit in a streaming, in a feed. Whereas this example, we are going into the database and looking at the people who are taking allergy medications, and then creating a simple pie chart to say, okay, how many of my population is taking drug X versus drug Y, which I have it at my disposal. For instance, a let's assume this type of a system is deployed in a clinical practice where a physician wants to go and see, okay, I wanted to see how many of my patients are taking various type of drugs which are related to allergy, right? So this example, let me call this allergy. Again, in the acquire, I am basically saying instead of channel, now I am getting it from data, and I have this data called EMR, and I am calling this EMR data. Now I have to synthesize this data. This is where the synthesize part comes in. Okay. Oh, sorry. 1 second. And in the action part, I am basically saying create me a pie chart of EMR data. Okay. Now, this particular one, again, it's not hooked up, it generates the code, we have to go and run it manually, and we have not hooked it up yet. So, where you can run it from the editor itself directly. So, now you can go to these pie charts when I run this. So, I will be able to basically look at this particular chart, where now that few lines of code led into kind of a visualization where I can go and look at various drugs taken by my patient population within my database, and they are grouped by that allergy conditions. So, this is just another example where a end user who has a knowledge about the data, not necessarily have an understanding of programming or IT, can do such type of things using this projectional editing and DSLs. Okay. Then there are a couple of more examples I just wanted to quickly go through. One of them is basically creating what is called as a snowbird use case, which Murali talked about briefly, where in this example I have 5 users traveling from point A to point B, right. They are going to make 5 steps on their way from point A to point B. As they travel, we are going to look at their conditions, if the person has an allergy, and where the person is traveling to as a alert in case of pollens, send kind of a notification back to them saying that, hey, now you are entering into this area, the pollen count seems to be high. It's just a notification, right. So, unfortunately, in the demo we are not able to send the notification, but what we are going to show here is just a mechanism of just changing their colors to say that, hey, in the map you are moving from a point where there is a low pollen allergy to an high pollen allergy, and you have an allergy condition, and hence you need to take some precautions, right. So, here is the DSL for that. Instead of typing it in, I will just go through and quickly show. So, basically acquiring the data from GPS, data from the EMR, but every data coming in from the patient, it also has a patient ID, some sort of an identifier. Just take only that record from the EMR, and then take the pollen data from the pollen database. So, you need all these 3 data to determine a patient has an allergy, and he is in a location where he needs to be notified of, and then basically execute the action. So, you need all these 3 data sets. You need the pollen data for the location, you need the EMR data of the patients, and you need where the patient is right now sitting. So, the first step is getting the data from the GPS stream. Second step is getting the EMR data from the database, but just for the patient for which the stream is sending the data, and then get the pollen data from the pollen database, but just for the location through which the patient is sending it, and you call this in 3 different names. Now, in the synthesize part, you basically say for EMR for a patient, if the patient has an allergy and the pollen data for location has a high pollen, then name this conditions high pollen. Okay, that is it. Then in your action phase, if they just draw that GPS coordinate on a map, mark it with red if it is an high pollen, mark it with the blue if it is not high pollen, as simple as that, right. But again, you can now add a step in action where you can send some sort of a push notification back to the user saying that you need to take care of this condition because you are traveling to a location where you need to take care because you have an allergy condition. So, that could be the next steps, but right now in the demo we are just going to show the changing colors of the map icon. Okay, let me run this. Now, I'm just going to publish this messages. Okay, so you have all these 5 patients located at different point in time. They're all blue right now because they're all starting from their home location. Okay, now the next epoch they are traveling to a different location, right? Now each one of them will be traveling from one location to another one. Where is this? Next. Okay, now each of these patients will be traveling from one location to another location. So the G has moved from Pennsylvania to wherever that MD is, somebody moved there. As and when they move, if their condition change, then they actually be read, because here this is where patient E moved from a location A to B, where when he moved and when he or she moved, the condition has worsened and the person has a pollen allergy, and hence a notification is sent. Here instead of notification, you are just basically showing this as a red marker to indicate that this is what happening. So with a very simple, again, a few lines of code, without having to type in and all, with just purely using projectional editing, you can just write this up, and it doesn't require basically an IT background or a data, understanding the data background. It's more of self-describing data sets with intuitive kind of a projectional editing, so where you can quickly whip up this type of use cases in minutes as opposed to doing it. Okay. Now, there are few additional use cases. Again, I'm just going to quickly go through just the DSL part of it, the pollen allergy. So here is an example of just taking the data from the EMR database and just doing some sort of a logistic regression on the data, train a model and just classify the data. Just a few lines of code, you can do it, right? So what we have done so far is did this POC and started developing this type of a DSL framework. This DSL framework doesn't really care about the underlying technology, right? It just creates it is mostly an abstraction over the underlying technology. What we are hoping to do is develop the hooks between the DSL framework to support various tech stack implementations of this type of an acquire, synthesize, learn, and action or a visualize framework. I think that's pretty much it, right? So I'm going to switch over to the slides. It's coming up.
Next. Okay, so to summarize, we talked about the few technologies that we identified to put an end-to-end story, right? Typically, when you develop an enterprise application like this, you will have to assemble a team that is very proficient with, dealing with, message transport protocols, security, portals, UI, SMS, all that stuff. And what you really saw here was, giving the tool, to select, few IT professionals or even data scientists who can really visualize some of the streaming objects and the data that they are really transmitting, and being able to build a robust application with a few lines of code. That's basically what you saw. It shows you how you can abstract away some of the technological complexity. So by working at the meta layer, you can really abstract away the technical complexity and dispatch all of your computations to the underlying layer, right? And obviously, you can embed them with all kinds of APIs to call visualization libraries or all the machine learning libraries, et cetera. So that's basically what we saw. I wanted to close with a few comments. The amount of data that you're really collecting from IoT devices is really going to usher in new opportunities for us to do new innovative things with getting preventative practices in place. The key here is to have good standards and good interoperability across various sources of data. We are indulging in some of the prototyping and would really like to engage the community. So if you're really interested in this space and would like to work with us, see us after the meeting. We would love to talk to you. And here's the contact information for you to get in touch with us. Thank you very much.